All right, so what we have here are two different demonstrations of the same physical principle. That is the principle of inertia. Inertia is an object's tendency to resist changes in motion. And you might have heard of this in conjunction with Newton's first law of motion, which says an object that is at rest will remain at rest, and an object that is in motion will remain in motion unless acted upon by an outside force, which is Newton's first law of motion, sometimes called Newton's law of inertia, because that's telling us the same thing as the definition of inertia. Objects will resist changes in motion. So if you want to change the motion of an object, you have to apply an outside force. So I have two demonstrations here of inertia, of objects resisting changes in motion. The first one, we have this milk bottle, and I have a little coin, but in between, I'm going to put this cardboard hoop. I believe this cardboard hoop is just cut right out of an oatmeal container, but it works. So obviously the coin is at rest on top of the hoop, on top of the bottle. What I'm going to do is I am going to hit this hoop and the coin will drop straight in. Here we go. The coin falls straight down. That's because it has inertia. Even though I'm hitting the ring and the ring goes flying, I apply a force to the cardboard ring. The coin resists changes in motion. It has inertia, and so the coin is at rest and it stays at rest until gravity makes it fall straight down. Now, with this particular demonstration, when you hit the hoop, you have to hit it on the inside of the hoop. And we believe that the reason you have to hit the inside of the hoop is when you hit the inside and it starts moving, picture this in slow motion, it will drop down as the ring shoots out. But if I hit the outside of the hoop, it does the opposite, where it compresses and bumps the coin up and it won't drop straight down. It's kind of being launched at that point. But if you hit this on the inside of the ring, it's almost foolproof, especially if I can do it, that the coin drops straight down into the bottle. So this is demonstrating inertia. The coin resists changes in motion. The other demonstration we have of this is this stack of washers. I'm going to stack them up. I have 13 washers here. That's just the random number I grabbed out of our bucket. And I've got a thin metal stick that I'm going to use to hit the washers. So what I'm going to do is I'm going to slide this metal and I'm going to hit the bottom washer in the stack. Watch close. The rest stayed still. I'll do it again. They have inertia. There's a little bit of friction in between them, and you can see our entire stack kind of has a lean to it now. But that's because when I hit them, I'm only applying a force to the bottom washer. So the bottom washer has an outside force applied to it. Objects at rest will stay at rest unless there's an outside force. So when I apply an outside force to this bottom washer, it shoots off. But the rest of the washers have inertia. They're going to resist changes in motion, and I'm not applying an outside force to them. But you can see, obviously, they start to kind of slide, and that's because there's a little bit of friction in between each washer. So when I hit the bottom washer, there's a little bit of friction that acts on the second to the bottom washer and pulls it out, pulls it to the side. But as it starts to lean, these top washers are in the same spot. That's because they have inertia and they're resisting that change in motion until eventually they all fall down.